Assalamu alaikum. Part 3 of lecture 1. We are talking about tetrahedron. The tetrahedron means that a pyramid shape of oxygen ion, 3 oxygen ion in a level and 1 on the top on the above level. Inside the tetrahedra there is a space, an empty space, and the empty space is filled with silicon and maybe aluminum. Generally, silicon is more suitable for this space. Here's another shape of tetrahedra. If you take the ion away from each other, you will find the silicon inside the space. Another shape here, silicon Si plus 4 and oxygen minus 2. So here is the net charge should be minus 4 because you have 4 oxygen ion times 2 minus 2, you will obtain minus 8, and here you have a 4 positive charge, then the net charge should be minus 4. Actually, in nature, there is different type of silica tetrahedra. Actually, there is 6 type. The first is a single silicate unit, like we discussed previously, and called nesosilicate, and maybe 2 silicate unit and called sorosilicate. How 2 silicate unit? I will show you how it combined to each other. Maybe 3 or more silicate unit or tetrahedra here, and called cyclosilicate. Maybe enosilicate, it means a chain of silicate, maybe single chain or double chain. Phyllosilicate, it means a sheet of silicate unit. The last one is tectosilicate, 3-dimension silicate unit. The first unit is nesosilicate or single silicate unit. We discussed this unit. I told you 3 on a level and 1 on the top of the 3. The empty space is occupied by silicate. A sorosilicate or a double silicate unit, it means that 3 on a level and you have 1, 4, and another the second tetrahedra shared oxygen ion with the first one. So there is here a sharing of ion oxygen between 2 tetrahedra. If you look to this part, you will find a tetrahedra, but however, if you look to the other part, you will find another tetrahedra. There is the oxygen ion is shared here between this tetrahedra and the other one. So if you would like to write the chemical composition of this tetrahedra, here it's easy to write the chemical composition. Here there is 1 silicon and 4 oxygens, and its chemical composition should be SiO4 and has a 4 negative charge. Here the chemical composition should be you will found 2 space here occupied by silicon, here 1 and here another one. Here is the chemical composition should be Si2O 1 2 3 4 5 6 7 O7 Si2O7. This is called the chemical composition of sorosilicate or double or 2 silicate unit, and the ratio of silica to oxygen is 2 to 7. The second type of silicate found in nature is cyclosilicate. The cyclosilicate, here in cyclosilicate you can find 3 or more of silicate forming a cycle. The cycle here contain 6 silicon ion. 1, 2, if you have a 6 tetrahedra, then these 6 tetrahedra will share how many oxygen you can count, but instead of counting all of these oxygen ion, you can determine the ratio in one tetrahedra. How it come? If you look to this one tetrahedra, due to this ion oxygen is shared between two tetrahedra, so we can count it as a half ion, and the other also as a half ion, because this ion is shared between this tetrahedra and this tetrahedra and that tetrahedra. So the silicon here will have how many oxygen? I will count as follow: 1, 2 and a half, then 2 and a half, and another half, 3. Then the ratio should be SiO3. The ratio of silicon to oxygen should be 1 to 3. Look here, 1 to 3. And if you have a cycle of 6 tetrahedra, its chemical structure should be Si6O18. For each unit here, the one silica have 4 positive charge, and the oxygen have 3 times 2, you will get 6 negative charge, and the net charge should be minus 2. The fourth tetrahedra is a chain of silica tetrahedra, and take this shape. Look, this tetrahedra and that, this and that. Each one is on opposite position. So you will find also the tetrahedra is shared oxygen on 2 ions. So the net here, or the ratio of silica to oxygen, will be 1 to 3, SiO3. For this tetrahedra, you will find double chain, double inosilicate. Here is a single. If you look to above or above silicate, you will observe that you get a single chain, but there is another chains gained on this oxygen. So you will find tetrahedra shared with 3 oxygen, and on the same unit you will find tetrahedra shared on only 2 oxygen. So if you would like to count, you should take 2 tetrahedra, one shared on 3 ion oxygen, and another which shared on only 2 oxygen, and count to determine the ratio of Si2O. So here should be Si2 and oxygen shared here half and half and half, 3 half, equal 1.5. Count here 1, 2, 3, 4. 4 plus 1.5, you get 5.5. So the ratio here between silicon to oxygen is to Si2 0.5, or you can say that it is 4 to 11. 4 to 11, because 5.5, if you multiply in 2, you get 11 here in SiO2. So the unit here is shared Si ratio to O equal 4 to 11 on double chain. The fifth most important silica unit is phyllosilicate, or a sheet of silicate, which is built on one direction, on one level, and produce a sheet of silica. You can imagine that by 3 oxygen ion is shared with the other tetrahedra, and all 3 oxygen on a level are shared, with exception the oxygen ion which is on another level. So it looks like a guy's seat, while it has head on above. Only the head appear, and all of the guys are seat. Uh, so so here the ratio is, if you have 3 shared, and 3 3 halves equal 1.5, and you have 1 half 2.5. So each silica has 2.5 oxygen, or each 2 silica have 5 oxygen. So the ratio is 2 to 5. The ratio here is 2 to 5. The last type of silicate is tectosilicate. In tectosilicate, all oxygen ions are shared, and consequently the tetrahedra is built in all directions, in X, Y, and Z, and consequently, due to all oxygen are shared with the neighboring tetrahedra, so its chemical composition should be SiO2, and has no the net charge is equal to 0. Has no charge on these. There is no charge on this unit, and it has a chemical composition of SiO2, like quartz, and this type of mineral is has no nutrient, just building a skeleton of Earth's crust. Do not contribute to the infertility or any on its ability to absorb water and so on. These minerals usually found on coarse fraction, like a sandy soil. You can find this type of mineral in sandy soil, and has no charge, and do not able to absorb any nutrient, because it has no negative charge to be able to electrostatically absorb nutrient. This all for silicate. If you look here, summarize the previous discussion, and also you can calculate the net charge for each unit. Thank you.